Today is Tuesday, November 3rd, and you're watching Amateur Radio Roundtable. We meet every Tuesday night at 8 o'clock, and since the time has changed, the time now is 0200 Universal Time, UTC, on Wednesdays. So on Wednesdays, 0200 Wednesdays, which is equal to 8 o'clock p.m. Tuesday. There's I think it's a 5 or 6 hour time difference. I always get that confused, but anyway. Welcome to everybody out there. Thank you for joining us. We'd like to invite everybody out there, please join our Facebook group. We've got a link at the top of the website where you can join our Facebook group. Also, you can join us on Twitter, and you can also click on joining our email distribution, where we send an email out every week to about 8,000 hams to give them information on what's going to be on the show that night and any future broadcast. So you'd get about one email per week from us there. Hey, Twitter is very powerful. We've just got on it recently, and I'd like to ask everyone out there right now, I can tell we got a high-tech community out there. I'd like to ask every one of you right now to get on Twitter and just send a tweet out so your followers can see this. I want to see the power of tweeting, the power of Twitter right now. And I'd like to have every one of you just send out a quick tweet that says, live ham radio show on W5KUB.com right now, and send that tweet out, and let's see if our numbers spike up here, and see if tweet really does any good for us. So hey, tonight we're going to do something a little bit different. We're calling an HFnet, I think, during the show. At least that's what I was told. Rich Olson W9TIT is supposed to be calling a net on 7278. Now, if there's somebody there, of course, it'll be plus or minus a little bit. But we just wanted to see if we could round up a little HF activity from people that watch the show. So, if you got a HF rig next to you there, tune into 7278. Look for a Rich W9TIT for the Roundtable net. Tonight's the first night. We hope it's not a flop. Give them a call, just check in, say hello, and let's see if we can establish a subtype net. Maybe we move it before or after the show. Tonight we got a great show. We're going to be talking about antennas, antenna basics. We're going to be talking about the hex beam. Our resident expert, Emmett Hohensee W0QH, the chief engineer of Radio Waves, is with us, and he's going to be talking about that. But first, let's check in with Riley Hollingsworth, K4ZDH. Riley is the retired special counsel to the FCC, and he has a regular spot on our show to answer questions. So let's see what Riley has to say. Riley couldn't make it personally tonight, but Riley did send a video and an audio track. So I'm going to play, these are some of the questions that came in this week from Riley. So here we go.
Hi, Tom. Thanks for having me on your show. Yeah, I appreciate it. And tonight I wanted to cover a couple of questions that I always get, no matter where I am and no matter what the radio event is. And then I'll cover a third question regarding California specifically, and I'll do that just briefly. But I always get two questions. One is, has rule compliance and the general conduct on the bands deteriorated in the years since the FCC eliminated the requirement to learn Morse code? And the answer is no. There's been a decline in politeness in society in general. But not just not in the amateur radio service specifically. Society generally these days, we're rude, boisterous, and we're quick to take offense. But none of that's related to eliminating the code in the amateur service. Amateurs are just a cross-section of society, and we want it to be that way. And there has been nothing that you can attribute to eliminating the Morse code requirement. The level of compliance is not related to learning the code. I thought in the early days that the code was a filter to and keep out people from in amateur radio that weren't entirely serious about it, but found out over the years that's quite not the case because, and this leads to the second question, which is what class of licenses causes the biggest problem in the amateur service. And it's nothing related to the code. If you look at the worst violators in the amateur radio service today, and the same applied 10, 15 years ago, they're usually extra class licensees. It's not the licensees that never had to draw a Colpitts oscillator, for example. It's not the licensees that didn't have to know the code. It's the licensees that think they know everything. You'll hear them on 75 meters at night. You can hear them out in California. You can hear them in New England. And you'll hear them on 20 meters too. Certain portions of 20 meters. They think they know everything. And they have all the answers, but the reason they have all the answers is they haven't thought of all the questions. They don't like anything new. They don't like new people. They've been using the same frequency for years, every night or every afternoon, to talk to relatively the same people across a couple of states, and they've been using 1,200 watts. They have thousands of dollars worth of equipment, and they act like a juvenile delinquent with a handy-talkie. And that's the best that can be said about them. Some of it is not rule violations. A lot of it is. Some of it is not a rule violation. A lot of it is just being stupid. And my grandpa told me once that dead people probably don't know they're dead, and stupid people probably don't know they're stupid. And that goes for the amateur bands as well. The other question that I got related to interference problems in California, particularly around certain frequencies on 75 meters, and the question was, has the FCC given up on that? And the answer is that they have not, but the FCC has varying priorities, and a lot of times they have to pick and choose among cases, and at any given time they have to decide whether to pursue a complaint that involves dozens of people or a complaint that might involve hundreds or thousands of people. But they will eventually get to it. Some of the interference out there that's being complained about, some of it is not rule violations. Some of it, again, is just people being stupid. A lot of it is a rule violation, but not all of it is. And the FCC has to take its time and pick and choose its cases and handle these cases carefully, and they will. And to the people participating in such malicious interference, I would say only the following, and that is TikTok. The FCC will get you when it wants to, on its own time and on its own terms. Well, that's it for this evening, and I appreciate being on, as I said, and I hope you folks have a good week. Thank you.
All right, that was Riley Hollingsworth answering your questions. And please send any questions you have for Riley to askriley at w5kub.com. And if you put a phone number in there, Riley may even call you back. He's been calling a lot of people back on the phone and talking to them personally. So if you'd like to get to know Riley, please send us a note in and ask your question there. Riley had a good comment there, I think, from his granddad or whatever. Stupid people don't know they're stupid. I thought that was pretty good. I'll have to start using that. So let's see. We've got two nets going right now, or at least we're on 38, 35 right now, and 7277. Rick W9TIT is on 3277. So hey, let's see if we get any check-ins. It'll be interesting to see if we get anybody that checks into our very first amateur radio roundtable net. So let's move on to our antenna segment with Emmett Hohensee. Emmett was supposed to be on with us last week, but we had a lot of internet outages in Missouri caused from weather conditions out there. So Emmett, how you doing today?
Good morning, Tom. Actually, I know. Good afternoon. It's morning somewhere. At least
Yeah.
in South Korea, where my son is stationed, it's morning there.
South Korea. Let me ask you a question. Where in South Korea is he? Is he in what branch is he in?
I really would not want to discuss what, who, where, when, and how for obvious security reasons, but let's put it this way: he's right along the line.
Okay. Well, I was stationed in Korea back in 1972, And I guess I was about 50 miles south of the DMZ there, at a place called Osan Air Base. Oh,
Back in my day, which was back in the 70s. But anyway, that's
yeah, I have to apologize. I just now, my producer here told me to turn your audio up, so I just turned you up,
Okay.
Emmett. So
Can you hear me now?
people can hear you now. So what did you say that I missed that you want to say again?
Oh no, I used to fly into Osan back in my day.
Okay.
We used to fly in, do our thing, and fly back out again.
Okay, cool. Yeah.
As a matter of fact, give you an idea. See if I can find that.
Yeah, I had a job. We worked up on a hill, a real tall hill, and they had a bunch of antennas. And we flew drones over the China Sea out there and caused all kinds of problems while I was over there. But didn't get the war started back up. You know, it really never ended, but we didn't start it. You know.
There you go. One of my antenna systems I used to play with many years ago.
Okay, and we'll see where. Okay, and is that in Korea?
No, that's someplace else in the world. It's
okay.
It's a PAR radar antenna system. It's for looking over the horizon.
Oh, okay, over the horizon. OTH.
Yes.
Isn't that kind of what the Russian woodpecker thing was?
Yeah, that's kind of one of the things they would do. The other thing about stations like this too is we could also pretty much jam their stations or match their frequencies and mess up their readings.
Yeah, no wonder the HFNs were so messed up back then, man, with all that stuff going on.
Well, they still use it, and that's
Yeah.
what's kind of interesting. Just even in the world of radar, you know, you'd think that the new radar systems are in the gigahertz and frequencies, but there's still some really low frequency radar systems out there, and they still work just as good. As a matter of fact, there are some amateur radio operators out there that use 2 meters and 440 and all these other different frequencies, and they're able to, based on, you know, sending a real quick blip and the return, be able to figure out, you know, what's where and how far away something is.
Oh, yeah. Hey, you know, it's funny. Let's see. We've got, you know, somebody just checked in on the chat room, said he was in Osan, 77 or 78. I just missed him there by about 5 years. That was
Yeah,
Ken.
I was. That's about my time frame. I was in that part of the woods in 78, 79,
Okay. Cool.
and so on.
Cool.
But I was just a troubleshooter, you might say. But back in the day, that was kind of an interesting period of time. Back in the Cold War, back when you know, we're just finished up with the Vietnam War, and we're just trying to get our footing on and seeing where everyone's going and all the politics that went on back then. But anyway, yeah, that was kind of fun. And having my son stationed at the same locations that I was stationed at is kind of an interesting and extra treat for me.
Oh, yeah, cool. Okay. Well, look, let's talk about antennas tonight. And I know
right.
we've got a lot of antenna discussion. So where are we going to start?
Okay, let's start with where we left off last time I was on with you. And oh, by the way, sorry we weren't able to make it last week. I live out in the country, and sometimes that cable does not always work when the weather hits or when someone hits the telephone pole or the cow decides to knock over the box. Not my cow or anything like that, but someone else's cow. We have little problems off and on. So sorry about not being here last time. We really wanted to be there. This week, what we're going to do is we're going to pick up where we left off when we were talking about the, you know, a lot of people had asked us about our slide rule, in which it's a slide rule designed specifically for calculating how long of a wire or what your antenna length would be if you put it together. Right. And so what we're going to do is I'm going to first take you to the website, which will be the Radio Waves website. And that's at www.radiowavz, that's RADIOWAVZ.com. Okay. And what you'll do is you'll go up to the section that's called Antenna and Data Information. You click on that, and that will bring up a really nice little subdirectory or a little section of our website that we set up specifically for helping people out as far as, problems with antennas. As a matter of fact, when we get phone calls at the shop, a lot of times we'll refer people to this location so they can download some of these manuals like the slide rule or the United States Army Antenna Systems Manual or the Antennas and Propagation Manual. Those are very good things that I think everybody should have printed out and close at hand, because it covers the fundamentals in a very simple way. It's understandable and visual at the same time. I believe that it's one of those things that quite often when we are having problems getting on the air, we have a tendency of forgetting some of the fundamentals. And you need to remember that even though we have got some of the most spectacular equipment in the shack, we've got the computer that cost almost $1,000. You've got the radio, which can cost anywhere between, a couple $100s to a couple tens or 20 of thousands of dollars with the amplifiers and all that. The one thing we don't remember, or we have a tendency of forgetting, is that 66% of everything that has to do with communications happens outside of your shack. In other words, if you were to take a look at the diagram, if you wanted to take a look at the diagram of a transmission circuit, you'll notice that you have the ground, you have the signal source, and you have the antenna. Well, the ground and the signal source are both outside. And if you don't have those two fundamental things working properly, it doesn't matter how much money you spent on your shack inside, how good your microphone is, how good the amplifier is, or how good whatever is. If either of those two things aren't working properly, you're not going to get out very well. So anyway, now what we're going to do is we're going to go down to the bottom section. You can see my little arrow, and I'm going to click on slide rule. And what that is a PDF file that you can download and then print out on your LaserJet or on your printer. I suggest what we've done is in the past is I printed out on some nice photo paper, and it prints out just like that, okay? And then you can cut it out. Now the way I designed this size-wise, I designed it so that, where is one? They're never around when you're looking for it, but they're always around when you don't want them. Anyway, this basic disc right here, there we go. Let me see if I get my orientation right. Okay, this disc right here, there we go. This disc will fit literally on top of a CD-ROM. So when you cut the both circles out, you can put one section on a CD-ROM, and then you can put the other one, laminated or whatever, and you put them together. And in this case, I just put this together a little bit before the show, and what I did was I just used a little pin to take care of the center. Now what you're going to do, you'll notice on this little slide rule, is that you have a 1, okay? That 1 represents 1 wavelength. Okay, you got a 1/2 marker, that represents a 1/2 wavelength. You have a quarter, and you have a quarter wavelength. So that's kind of how that all works. Whoops. Lost my little pin. I should have put a little bit better pin in there.
Oh man, I like your idea about the CD. I mean, I can cut this out and
Yeah.
glue this. I can glue it on my CD, and
Yeah.
I can keep it in a CD case.
Yes, as a matter of fact, you can. Then once you laminate it, it's like a really nice thing. So what you're going to do is you'll have 2 rings. You'll have an inside ring and an outside ring. Okay, the outside ring, you'll see where this great big red 1 is, right there. Okay, what you're going to do is you're going to say, okay, let's say I want to figure out what a 1/2 wavelength of a, let's say, what was the frequency that he's on right now?
38 something.
Okay, so we're going to put the 1/2 on 3.123. That'll get me in the ballpark, okay? You see where the 1/2 mark is? Right there, about where it's supposed to be?
Right.
Now what you're going to do is you're going to go up to the number 1, and that number down below tells you basically you drop the point, you move the decimal point over at it's around 65 feet. So a 1/2 wavelength antenna, generally speaking, now that's it's not always exactly, but it gets you in the ballpark. That's how long the wire is going to be for the 1/2 wave antenna. But let's say we're just going to go with a quarter wave. We just want to figure out what one side of the dipole is going to be. Okay, so I move the quarter wave right to there. Okay, then we go back to the 1, and you'll see that the length is about 32 and a half feet. Not bad, huh?
That is cool. I like it.
This is one of those products that I really believe that just about everyone should have. It takes a little practice to learn how to use it, but it's an excellent thing to have in your toolbox, especially if you do emergency communications or whatever. The nice thing about the way the slide rule works is that I have it broken down to where you can even work in the gigahertz, and I've done it before. It gives you a good idea of where things need to be measurement-wise. Now, I know that with the propagation or the ground situation in California is going to be different in New York. Like I said, it's going to get you in the ballpark, and in an emergency, it'll be good for just getting you where you kind of need to be in order to get on the air. So it's pretty simple, especially if you're going to just use like an extension cord, split it in half, use the wire out of the extension cord, and then cut the two pieces to the right length. It's that simple.
This is a great slide rule here. I've used it a number of times myself. Now, you mentioned slide rule. This is very easy to use. Now, Emmett, we've got probably a lot of young hams. I mean, I'm getting pretty old here. We got a lot of young hams on here. Probably don't know what a slide rule really used to look like. I think you've got yours there.
Yep.
You've got yours there. Let's see. Let's just compare slide rules now, guys. This is what a computer was. This is what a computer was in 1966, right here. And believe me, you had to have a computer brain to actually figure out how to use this thing. But this is a slide rule. And Emmett, did you put baby powder on yours when you had it?
Yep. As a matter of fact, I still do. I still use this slide rule.
Do you?
Well, honestly, I have found, just like with calculating, when I'm in the shop and I have to figure something out fairly quick, I don't necessarily go to my iPhone and start typing in a whole bunch of formulas. I just go to my slide rule, and within about 2 or 3 movements, anyway, how do I say this? I can pretty much figure out what I need to figure out in about 2 or 3 movements. And I'm not having to go through a lot of iterations on the keyboard and making sure I type in the right number. I'm there, which I kind of like.
Well, I hated that thing in engineering, and believe me, I was born just a little too early. I would love to have just the calculator where you hit the buttons and it gives you the answer,
Okay, now this is another slide rule that I did with ICOM, compliments of ICOM. If you download this one, you just cut everything out. You cut everything out of your out, and then what you do is there'll be a little section in the middle here that you have to cut out too. And what you'll notice is I've already got the lengths already calculated, in the tool itself. This is a nice thing to have too, because it pretty much tells you, for instance, on 12 meters, at whatever the frequency is, this is what the length is supposed to be. And then we've got a couple really nice calculations on it as far as, how to figure out wavelength and so on. Plus we've got another nice little thing on the back, which gives you, your power equations and so on. Plus some really good links on the back, ICOM America, radio waves, obviously, ham study, and so on. This is a nice thing to almost a no-brainer kind of a thing that you can download, and it won't hurt you any trying to figure out or remember how did that slide rule work again. So it's a pretty good tool to have, and it's a good tool for people who are just starting out and they need to have an idea of what kind of antenna I need to have, how much space do I have. Quite often, the amount of space that you do have is not enough to fit the kind of antenna you need to work on the frequency you need to work on. Okay. Anyway, but those were. I'm gonna go here to the thing real quick.
We're gonna kind of try to watch the chat room, and as you get into these antenna questions, if any questions come up, we'll try to relay them back to you.
Yeah, I was just looking there. Anyway, I just got a couple people are messaging me from different locations outside of this broadcast, and it gets a little distracting, but that's okay. In other words, they're messaging me about they're watching the show, which is cool.
Yeah, cool.
Anyway, I've got another little thing that is kind of interesting. Riley, in his discussion, in the video that you just played, I really appreciate what he said, because the whole idea of eliminating Morse, or having Morse code or not having Morse code. Some people would have thought that the Morse code issue was one of those things that it was there because only serious people would learn the code and then get their license. The reality is that the society that we live in today is a little bit more based than it used to be when you and I were younger, and things were a lot more civil. It doesn't matter. People who know the code are still just as base as they are without the code. And I personally see, if you look at some of the bands, like on 10 meters sometimes, I see a lot more activity on 10 meters than I have in the past. And I think that's because now that it's not required that you learn the code, more people are using the code in different digital modes. And anyway, what this does is that I'm going over to a site real quick here. I was going to introduce it to you. It's about learning Morse code for those people who are new. Just to give you an idea, back in the day, I got my novice license when I was 8 years old. And back then, it was one of those things where you couldn't, how do I say it? You didn't necessarily have VE testers. You actually had FCC testers. So it wasn't something that you could just get away with, oh, he's a kid, just, he'll pass, you pass him in there, because he's cute and all that neat stuff. And I was cute. Still am, actually.
So
Anyway.
about what year was that when you got your novice license?
1968.
Okay. I was going to say I got my license 64, and I know what you're talking about. You had to go to the FCC. They came here 4 times a year. That's the only time you could take the test.
Yep. As a matter of fact, when I got my original license, not my tech, my novice, but my I forgot what license I got after that, we had to go down to Kansas City to do the test instead of we were in Omaha. And anyway, that's a long story. But the thing is for me, Morse code has been part of my life all my life, and it hasn't been till just recently that I really haven't been using it, but I'm going back into it again. The main reason is that there are so many reasons for learning Morse code, and it's not just for communicating. In an emergency, the easiest way of sending a message, how many times, think about this, Independence Day. Remember that movie, Independence Day? The aliens that come down to the earth and they're trying to communicate all the way around the world, and all the radio frequencies are all jammed up, except for the Morse code frequencies are all working. And so what they're doing is that they literally communicated using Morse code. That was just a movie example of Morse code. But I've had situations where I've had to signal people at a distance using Morse code during a search and rescue mission, and good luck for me, I had someone on the other side who understood it, so we were able to communicate because our radios weren't necessarily working at that time. Also, it was kind of cool in school, and this is in junior high, a real good friend of mine, Del Botkin, and I both had new Morse code, and we'd be sitting in class communicating with each other over code, and everyone thought was that we were just tapping on our desks. So think about that. That's kind of cool. Unfortunately, sometimes he would say a joke and I'd start laughing, and no one could understand why I was laughing. And neither of us told anybody what we were doing, so no one was any the wiser about that. But anyway, going back to the code, what I'd like to do is show you. There's a really neat new site that's available that has just come out, and it's called Enjoy the Code. That's ENJOY the Code, THECODE.com. And what it is a man by the name of Lan KC7RUN, basically is putting together a really neat class on how, learning Morse code. And the first part of the whole lesson plan is free. So basically, he's got the whole curriculum for 13 words. He's basically giving you code at 13 words per minute at 5 words per minute spacing. So you're basically learning as you go. It's a really neat site. You can download the individual lessons for free, and I consider it to be a really nice service for people who want to learn. And Len is a professional broadcaster, so needless to say, the production is excellent. It's kind of funny, the last couple of weeks we've been going back and forth. He's constantly having me listen to all these different segments that he's working on basically just teaching the code, which is really kind of neat. So I would suggest anytime you can, I would recommend that you have other people, anyone who's interested in learning Morse code, or at least download the first section of audio as far as the first several letters, and just start learning, and then teach someone else at the same time. It's done in such a way that even kids, my grandkids, are in the process of studying Morse code using this system, and they seem to really grasp it, which I think is kind of cool. It's not the old, how do I say it? The old way we used to do it. Remember how we used to do it? We say, dot, dish, dot, dot, that kind of thing, and you had to figure out, okay, this combination of dits and dahs is this letter, and then we had to, figure things out from there. Where what he's doing here is he's teaching you how to, understand Morse code in more of from a linguistic standpoint. I guess that's a good way of describing it. Well, anyway, Len has done a great job on that, and I'd like you guys to try it out and let us know, or let him know, what you think about it. And Tom, I think he'll be trying to get a hold of you next week or so too, because I think he'll be an interesting person to have on the air as well.
All right, we'll talk to him. We've already got 2 or 3 really interesting shows coming up here. They're just kind of starting all to fall together, and I think they're going to be exciting shows. But we'll be glad to talk to him, and we'll see what we can do. So,
alrighty.
What else you got on antennas there today? Are we ready to get into the hex beam, or you got more on the antenna basics there you want to talk about?
Well, the big part was, I think, in our original, what we originally talked about when we first started out, is that quite often when you are working and even beginning to set up your station for the very first time, we have a tendency of thinking about what's right in front of us. We have a tendency of only understanding, or only really getting into those things that we have in our immediate reach. So things like the antenna outside, things like the grounding system, things like the proper power for the radio station that we're using, is something that we have a tendency of overlooking. And quite often, we can eliminate a lot of those problems by just simply, how do I say this? By just simply, addressing those things. One thing that you need to think about, we're going into the winter, okay? For those of you who do have stations, my strong suggestion is, before the weather really hits, go through and inspect your ground system. Make sure that all your connections to the ground, as into the ground rod, are physically not oxidized, that they're physically there, that you're not just holding on by just one or two strands of copper wire. If the copper wire looks green, disconnect your ground, make sure the power's off first, disconnect your ground, and clean up those connections. And then use this stuff called, it's a Penetrox, or it's a grease material that you can use. That's a sacrificial grease that has a lot of zinc in it, so that way it maintains the electrical connection throughout the winter. Reconnect things, and then go on down the line and check things out to make sure that those things are right. You'd be surprised how many people think that it's okay that, well, I've had this ground rod, ever since we moved into the house, this ground rod's worked just fine. Well, reality is that ground rods eventually glass over. It's called a glassing effect. And maybe one of these shows I'll go into a whole segment on grounding for you. and I'll bring some pictures in of what a ground rod looks like after 10 years, what some ground rods can look like after even 2 years of use. What happens is when electricity passes through the ground rod to the earth or vice versa, there's a small amount of electrolysis that occurs. And what will happen is it literally melts the silicate material that's surrounding the ground rod, and it literally does what? It glasses over the ground rod. So the ground rod itself is no longer as effective as it was when it was originally put in the ground. So needless to say, you need to check your grounding, make sure that things are still connected right, and if that ground rod looks green, it's time to either sink a new one or pull that one out and clean it up and put it back in again. Actually put it in a new spot, because that's just a socket that's been glassed over.
All right, so here's a question from KC7RUN. He
Yes.
wants to know why the Pathfinder antenna is so broad-banded and why the U.S. military uses it over other antennas. You know anything about that?
Originally we designed it, that antenna. We do a lot of work with special operations, and quite often operators need to go into the field and do something, and they don't necessarily have the niceties of having a tuner or having a lot of stuff that they can carry with them into the field. So they needed a simple antenna that they could put, carry in the thing you see on the screen is not the one that we sell to the military or the government, but it's like it. It literally will fit in their pocket, in their cargo pants pocket, and they can deploy it, and it works for them. It's a nice antenna. It's broad-banded. It's not the best antenna for everybody's use, but sometimes when you have limited space, 66 feet of wire will work miracles for you.
All right, and here's another question from Circuit. He's asking about an end-fed antenna with a coil near the end for better 80 meters. Comments. Now, I tell you, I know you guys have some end-fed antennas. I personally don't see how they work very well, and I really don't think there's such a thing as an end-fed antenna, because you've got to have some kind of counterpoise, the other half of that thing hanging or something, don't you?
Well, yes and no. Remember that an end-fed antenna, in the kind that I'll have to. How can you check if you're? I'll answer that one in just a second. The antenna itself is, in some cases, for instance, like our end-fed half waves that we sell that are specific for a frequency. What that is a half-wave antenna that we've set the feed point at the end of the wire or close to the end of the wire in reality. So what happens is in the middle of an antenna, your feed point impedance is generally on a flat top type antenna about 75 ohms. Right? Yeah, 75 ohms. Inverted V, it's about 50 ohms. Okay? And then what happens is as you move that feed point out from the center, that impedance increases. So what we end up doing is we basically make a matching section that matches that impedance, that feed point impedance, to the wire itself. And so what basically happens is instead of feeding it the dipole in the middle, we're actually feeding it more towards the end of the antenna at about 3,000 ohms. And it works, and it works just as well as a half wave, a standard half wave antenna.
So this is really kind of like an off-center fed antenna fed at the very end. You slide that feed point all the way down to the end.
There's only like about 6 inches on the left over on the other side of that antenna.
But tell me, you've got to have some counterpoise or something. Does it use the coax for the counterpoise side? I mean, I've seen some where you actually drop a counterpoise or something.
Yeah, it doesn't hurt to have a ground plane of some kind on any antenna. Some people would argue that with a dipole you don't need a counterpoise. In my mind, your earth ground is not that efficient, and this is the other reason why I say things like make sure your grounding is correct. In some cases where you need to, your signal is getting out, but it's not as good as it could be. Or here's a good one. I did great just after the rainstorm, and then 3 weeks later when it's really dry, you can't get out anywhere. Well, that's a good sign that you probably need to put out some type of a counterpoise or a reflective surface underneath your antenna, even though it's a dipole and it's resonant and everything else, just to get the portion of the radiated signal that basically what we want to do is we want to hit it like a bank shot. We want it to hit the ground and bounce off. Sometimes, in a lot of these computer models and stuff like that, you'll have all near earth ground, perfect ground, whatever. Perfect ground is where the signal gets radiated, it hits the surface, and it bounces off at 100%. Earth, a standard earth ground can be 50%. So half the energy that you use when you transmit with a dipole or even a standard wire antenna, that radiation that goes down and hits the ground, 50% of it gets absorbed by the ground. So it's wasted. Why not put something down there that will make the antenna work a lot more efficient? I've got quite a few people out there right now that have done exactly that, and it doesn't matter what time of the year it is, their antenna performs significantly better than it did before. Another good example is when you sometimes you'll be operating your radio station and the antenna's resonant at a certain frequency, then all of a sudden weather conditions come in and you notice that the resonant frequency or the impedance or something starts going off. That's another sign. Many times with wire antennas like dipoles and off-center feds and so on, we can't move that antenna like a 2-meter antenna where it's multiple wavelengths above the ground. So that wire that's over the ground is interacting with the ground and it's creating a form of capacitance. Okay, so it's reacting with the ground, and whatever you have underneath that antenna is causing things to happen. So a good example is, someone will put an antenna up in California where there's really no ground plane there, so the antenna will look short, and because there's just no reflective surface, and the ground plane really looks like it's maybe 100 feet below where the guy is. Go to New York where there's a pyrite and all this other stuff. The antenna looks long, the same antenna, the same length, same everything, but what basically happens is the antenna is interacting with the ground.
Yeah, let's talk grounds just for a minute. I know some antennas, like a half wave or whatever, doesn't require, like a half wave vertical, doesn't require ground. A quarter wave requires some type of ground system, but on HF, one ground rod is just not a very good ground to have. It's very not very efficient. Now, what I use out here, I've got several ground rods in the ground connected together, and I've got about 30 or 40 radios buried that all connect back to the ground rod to try to get a little bit better ground. So, I guess one ground rod might help you for a safety, electrical type safety deal, but it's not so good for RF, is it?
Right. Well, the whole thing is don't confuse signal ground with safety ground. Safety ground is safety ground. The whole idea is to mitigate an electrical charge or create or stop things like current loops and stuff like that could possibly kill you. The counterpoise system that I was describing for the antenna, many people, like I said, will say that because the dipole is balanced, it doesn't necessarily need a ground plane. You're right, it doesn't. But the reality is that your earth underneath the antenna, that wire antenna that you have, is not 100% efficient. So things like radials, that are cut to, let's say, a frequency that you like to use and put underneath the antenna at different angles will most definitely increase the antenna's efficiency, because the stuff that was hitting the ground is now being reflected back up versus the stuff that was hitting the ground is being absorbed by the ground. That's the whole idea behind the counterpoise. And that's a different kind of a ground. See, we've got like 3 different grounds that we have a tendency of thinking about. First, maybe we should just plan a whole section of, I can do a whole PowerPoint if you like in a show about grounding if you like.
That may be a long part of the show if we just talk ground. Tonight we're going to talk about the hex beam, aren't we?
Yeah.
Okay, we're going to talk about that. Just a quick question. You mentioned before in other talks we had, just lay a wire across the ground as a reflector. Now, let's say you got an inverted V or a dipole up. Typically, I put the dipole up or whatever, so I have radiation broadside, like east and west, But if you put a ground, or if you put a wire on the ground under that dipole, will it help the east and west, or is it going to help your near vertical stuff that's coming off of that?
if it's going directly underneath the antenna, it will definitely help out your near vertical. So for instance, if you're using let's say a 40 meter antenna and you want to talk to people, everyone in the people in South Carolina can hear, for instance, I'm in Missouri, people in South Carolina can hear me better. People close in can't hear me at all or rarely, but I can hear them. Quite often putting a wire directly underneath that antenna will help create, let's just call it a bank shot, straight up into the sky and then back down again. So yes, it will definitely help for close-in communications. As a matter of fact, one of the things that we used to do in the military for communications, and we needed to talk just, let's say, 75 miles away or 50 miles away, is we would do exactly that. We'd have our antenna at the height that normally is, but we would lay wires and literally create that bank shot to where we need to communicate by doing exactly that.
Okay, here's a question. We've got a question from KG5JVF Brian. How do you figure out how to consider the earth portion for your own geographic area? You know, I mean, some areas are rocky, some areas are sandy, some areas are clay. I don't know, unless you're a geologist. I guess just put a number of ground rods in and keep them wet. What's your comment there?
Believe it or not, there's some good reference in the ARRL manual on grounding, and it'll basically give you an idea of what type of ground surface you have. If you just look at those things, you can pretty much get an idea of what type of soil you have or what you have underneath your antenna. I've always typically, just about no matter where I go, regardless of the grounding conditions, I'll go ahead and put a counterpoise under my antenna. Why? Because it just seems to work a lot better. And no matter where I go, my antenna seems to perform the same way. So that kind of eliminates a lot of questions in my mind as far as, how's this antenna going to perform when I go take it? Let's say I go to New Hampshire to visit my daughter. I'll take that same antenna and I set up my ground plane. I'll set it up about 32 feet. This is an off-center fed DX80. And I'll put, I've got about 8 radials that I run out real quick. It doesn't take very long, just using garden spikes underneath the antenna in a star-shaped configuration. And the antenna works. I really don't even need a tuner, and people all over the country can hear me.
All right. We've got a lot of people who are interested in the hex beam. Do you want to jump into the hex beam, talk a little about it? I
sure can. It's been one of my this is one of those types of antennas that when George, who's the main was the main purchasing agent, who's now Silent Key at HRO, contacted me on a couple occasions telling me, Emmett, you really need to start looking at the hex beam as an antenna. It's a wire antenna, but it's a beam. And it just is perfect for what you guys do at radio waves. And of course, in the beginning, I looked at it, and as a wire antenna company, we, the whole idea of putting together structures and all that other neat stuff wasn't exactly too attractive to us because, one, we're a wire antenna company. We build wire antennas, and that's kind of what we focus on. And the whole idea of going to a beam type antenna wasn't exactly, I'd just say we didn't really think it was in our mix, but I started playing with it. The interesting thing was as I started playing with the hex beam, and this was about 7 years ago, I really started getting into to working with it. It was kind of funny. Rochelle, my wife, had it quite frequently would say, Emmett, get in here. And basically, I was working on it out at the shop, and I'm supposed to be doing other work, like building antennas or doing some custom work for somebody, but I was out here playing with the hex beam. And for me, a couple things I like to look at in an antenna system is, and the number one thing is it functional? Number one. Number two, is it resonant? Okay, in my mind, a resonant antenna will generally outperform, hands down, a non-resonant antenna. Now, I know some people will question that, but reality is that the laws of physics tell us that, a resonant antenna will generally outperform a non-resonant antenna. It's more efficient. You get more energy out for the energy that you put in. Okay, the one thing the hex beam is, it's a resonant antenna on a specific band. As you can see here, this is a beautiful shot I took one night while I was working on one of the hex beams. You'll see the nice little Yaesu GS450 rotator there. I've got some people who have just used TV rotators. The antenna itself is a whole 19 pounds. But you'll see in each one of these sections, the antenna itself has two components. It's a dipole, and you see my cursor running up and down, and then you have the back section is a reflector. So it's a 2-element Yagi that's being compressed. It's about 30% the size of a normal dipole. For instance, on a 20 meter hex beam or a 20 meter 2-element Yagi, 20 meter 2-element Yagi is 33 feet wide. The hex beam itself on 20 meters is only 20 feet wide. So that's a considerable savings in space. The other thing is the antenna itself is quite light. The whole antenna weighs a whole 19 pounds. To me, that's fantastic. I was trying to find the picture I took of Rochelle a while back ago, my wife, holding the hex beam like the Statue of Liberty. I thought that was the coolest picture in the world, and doggone it, it was on my iPhone and I can't seem to find it. But what you'll also see is, I'm going to zoom in a little bit. Whoops. There we go. Let me see if I can zoom in. There we go. Right here you can see the antenna itself gets fed at the top instead of at the bottom. Okay, which kind of goes against some normal the way you would normally think how things go. But you'd have the feed point at the top, and then what we have is a simple 50 ohm parallel bus that goes all the way down. And you've got your 20 meter element, the 17 meter element, 15, 12, 10, and 6 meters, all in one. And what's really neat about the antenna is that when, let me see if I can find it. There we go. There's a day shot of it. There we go. Isn't that cool how that just kind of zooms in there?
Yeah, that's cool.
Let me try and go down here. Okay, right down here we have a common mode choke. It's real simple. You see how everything's kind of bolted down. It's a simple design. It doesn't take that much to make this antenna work. And I guess that's the one reason why we decided to go with this antenna design as a product that we sell, is because, oh, by the way, do you see that little dot right there? That's actually a star. I didn't realize it, but my camera caught a picture of a star in the background, which was kind of neat. There's the feed point.
Mm-hmm.
Let me see if I can.
Do you feed that with a ballon?
Yeah, that's a common mode choke.
Okay.
Because the feed point impedance itself is at 50 ohms generally. So what we do is we give it a 50 ohm. We just give it a common mode choke because all we want to do is there we go. All we want to do is how do I say this? We just want to take care of any common mode issues that might occur, and sometimes because of the environment, those issues do occur. And this is really this antenna here is one of our other hex beams. It's a 40 meter hex beam. This antenna, basically the main element.
What's the diameter on your 40 meters?
I'll give that to you in just a second. The main element right here of the 40 meter element is a whole 40 feet in diameter. In other words, from here to here, it's 20 feet. Mm-hmm. The whole antenna itself is 40 feet from side to side.
Instead of 66 feet, you've got it down into 40 feet.
Yeah, exactly. And what's really neat is it handles full power, and it's directional like a 2-element Yagi. And of course, this is a good friend of mine, Ron, up in North Dakota. And as you can see, how he's did a really excellent job. Look at that. He even made a nice little fence around the tower so people don't, mess with it while he's away from home, which I think is kind of neat. And of course, it was just before Halloween, so he put that spider up there. He set it up so the spider keeps going up and down the tower during Halloween. I thought that was kind of a neat picture. See if I got another shot. Whoops. Go the other way with this. There we go. There you go. There's a little bit better shot of the 40 meter. And right here, he's got a It's not bad for a camera, huh? Look how that kind of
Yeah,
zoomed in there.
good.
What he's got is he's using he's not using the 450. He's using the Yaesu GS 800 rotator. He's got the base mount, and then he's basically got his center mass going all the way up, thrust bearing. He's using the hex plate. It's a tilt plate, so that way the antenna can rotate and when you bring the antenna down to service it, it can rotate out, so it's easily worked on. With the hex beams themselves on the 40-meter antenna, it's not a single feed point, because what basically happens on 40 meters is 40 meters and 17 meters do not generally play well together. So what we've got is we've got two separate feed points, one feed point for 40 meters, and then I've got another feed point right down a little bit farther down here for 20 through 10 meters. You see if I got there's another, that's one of our night shots.
And like you said earlier, the weight of that thing, maybe not the 40 meter, but you said 19 pounds. I mean, and,
Yeah.
and there's almost no wind. What do you call it up there?
Yeah. Well, what's kind of interesting is it's a balanced antenna. So what basically happens is there's really not a lot of wind resistance, and I've even got a video I'm going to show you in a few seconds here that is absolutely cool. But anyway, you can see how this is how the antenna really is supposed to work. You've got your feed point. This is the direction of radiation, and then you got your driver wire, which is one half a dipole, the other half a dipole. Mm-hmm. You have a spacer, which basically separates the reflector from the driver.
Yeah, so a small rotor could probably turn that pretty easy.
Oh yeah, and this right here is basically what the radiation pattern looks like with that type of an antenna. It's not tight like a laser beam, but it makes great for instance, we have a customer down in Jamaica who is monitors a maritime traffic on 40 meters. He's using it as a net control. Several people on the maritime mobile network on 20 meters use the hex beams as their main antenna for being net control. Let's see if I got another picture here for you. Sorry about that. Tell you what, ever since I started playing with these hex beams, for me it's almost like it's a work of art in my mind. Let's see, where is it? Give you an idea, that's what 40 meters looks like on the 40 meter hex beam at about 100 feet.
Now, in the chat room, they're talking, you got, for 40 meters, you have a separate feed line for 40 meters.
Yes.
So you got two feed lines, one for all the other bands and one for 40.
Yes, because 40 doesn't go well with 17. If you were to get rid of 17, you could feed them all together. Mm-hmm. Just recently, I went out to work with some real good friends of mine out at the Lewis and Clark. They're part of the Lewis and Clark Amateur Radio Club, and we did some work with basically it's a 20 meter hex beam, and we did the setup, and of course there's Zoe right there. She's our helpful dog. She's always there helping, and also supervising, of course. We basically set this up antenna on the ground. Okay, and this is in I forget exactly where in Illinois it is, but anyway, we set it up we set it up. We checked it all out. Let me see if I can find the picture. That's me, of course, right there. Good-looking guy with a good-looking dog. Yeah. What I'm going to do is I'm going to show you a video real quick. I'm going to switch over to my normal camera, and I'm sorry that I was not able to transfer this in time, but I want to show you what we did is right after we got done installing the antenna, we just set it down on the ground, 6 feet off the ground, okay? And he's playing with his, I think it's a Kenwood 470. It's an older Kenwood radio, but it was a nice radio. But anyway, I'm going to play this for you. This is his first contact with the hex beam on the ground facing in that direction.
There, Charlie Papa. Getting that. X-ray. X-ray station again? Whiskey number 9, Mexico X-ray. How's Larry there? Whiskey 9, Mexico X-ray Canada. USL, USL. Okay, 5-9, Richmond County, RIP. Roger that, you're 5-9, Madison County, Illinois. Madison County, Illinois. Illinois, thank you, 7-3. Keyword that, you're the wrong way.
All right, so you don't even have to put it up on a tower. Just set it on the ground.
Oh yeah. You see, that was the other part that convinced us that this is a good product to work with, because when I do a lot of my demonstrations, for instance, I go out to HRO and we'll set the hex beam up out in front of the store for the event, or we'll go to Gigaparts and we'll set up there, or AES. I'm operating while we're there, and we're only 10 feet, 15 feet up, and we're talking all around the country. Got one more video for you I want to show you. Remember I told you how the design of the hex, oh, that's not the right video.
There's a question about will it work in cold weather. The answer to that, of course, is yes. I think the only thing you got to worry about is the rotor freezing.
Yes, that is actually the answer right there. The only issue you've got is the rotor freezing. Okay, I've got oh, that's not the video either. Darn it. Where is it? Sorry about that. I'm trying to find this video that I had. Basically, it was the antenna itself, the 40-meter hex beam at 70-mile-an-hour winds. Let me see if I can find it real quick. Sorry, guys. I had it all set up there.
Well, we'll have to play them back on the webcast later. I mean, we saw the last video you were holding up. It wasn't great quality.
Yeah, I'm sorry about that.
Oh, that's okay.
But no, I've actually got the actual video on the computer here, but I was just trying to find it. I thought I had it laid out, but I missed it. It's basically the 40-meter hex beam at 75 feet in 70-mile-an-hour winds. And you'll notice that the antenna is really not doing anything. It's just sitting there. And the other video I used to have, too, was of another antenna design at 70-mile-an-hour winds, and you get to watch the antenna fly apart. But that's another story. That wasn't a hex beam that flew apart. It was something else. Anyway, let me switch over to the thing here. Yeah, I'm like I said, I'm trying to find that video right now. I was looking at.
While you're looking for it, let me ask a question here to our viewers. Guys, we've got a backup video running on YouTube, and if you'll look at the bottom under the video window, do not go to room 2. Do not go to room 2, but if you'll click on backup video server, you should get the same video, but using a different service. It's YouTube, and it'd be just interesting to see how the YouTube video compares to the Ustream video. So you might want to go there and try out the YouTube video backup.
Okay, I got it now. I'm going to switch over to the screen. I knew you guys would want to see this picture. Here we go. Okay, this is Ron's antenna. Notice the spider. Now, the whole idea behind the antenna itself is it is supposed to flex. So the idea being that, you know, it's just like a reed blowing in the wind. But you notice nothing really significant is going on with the antenna.
No, it's not. You know, when I had my 3-element Kutchcraft beam up, the wind blew, those elements moved around a lot up there.
Yeah, and I think what it really is the symmetrical design of the antenna.
Uh-huh. All right, let's see. How about the birds, man? Are the birds going to be sitting all over those wires, or are they small enough that they might not want to grip onto it?
Well, it's antenna wire, so I don't know. I haven't really heard a lot of people having issues. Now, They have had people where they've had owls fly into the antenna or geese have flown into the antenna. But like I said, the antenna is designed to bend and flex under extreme conditions. A good example is back in the time when one time when we were doing the demonstration out at Gigaparts, the whole the tripod base that I had set up broke, and the antenna fell down, and it was like 20 feet in the air, and it hit the ground. And of course, everybody was going, ooh, you kissed that antenna goodbye. All we did is we picked up the pole, the antenna snapped back into place. There was no problems with the antenna.
All right. Well, let's see. Is the SWR on a hex beam 2-to-1 across the whole of each band?
In many cases, yes, or very close to it. In many, the reason for this design instead of the double W's is that it gives you broader banded capabilities on the individual band. So in many cases, if you set things up right, it should cover the entire band without having to mess with the tuner.
Now, when you said double W's, are you talking about the reflector is not a W, that it's C-shaped? Is that
yeah,
what?
the reflector on our hex beam is in a C shape or a U shape, and the original hex beam is like two W's facing each other.
Okay. All right. So yeah, I haven't thought about this design using two W's, for reflector and a director. Are there any out there that do that? Are people using that?
Yeah, they do. As a matter of fact, Trefe, he's no longer in business, makes it just in that configuration. The advantage of that is that you get a little bit more gain, but you're not as broad-banded. And I decided to go with being broad-banded and being able to talk to the world versus getting just maybe a dB more gain out of the antenna and not be as broad-banded. Because when you start working on either end of the band and you're not as efficient, getting that extra dB in the middle isn't going to help you out that much. It covers the entire 60. For the question from Art, was it KB2FJD? Yes, it covers the entire 6-meter band.
Is there a ideal height for the hex beam? I'm going to guess maybe a quarter wave on the lowest band. I don't know.
Well, yeah, that'd be 6 meters.
The lowest band, 40 meters.
Oh, 40 meters, so that'd be 66 feet.
Yeah.
The basic antenna design is modeled at about 30 feet. The idea being that 25 to 30 feet is more than sufficient to work. A lot of the people who use our hex beams basically put it on top of the roof of their house. I've got one man who literally is attached to his chimney. And he put the rotor on the chimney, and there it goes. You got another guy who has got it set up on a heavy-duty tripod, one of those TV mast type things, and a rotor, and that's all he uses, and he talks around the world with it.
Another question, can it be mounted above a tribander? I would think that if you get a tribander, this beam is got the same same bands on it.
I've got one situation where a guy does have it above another Yagi, yes.
Yeah.
But if you put it below it, you have a problem. What happens is by putting it above the other beam, is the other beam acts as a ground plane for you, so it actually kind of helps out a little bit.
So if that's the case, then the hex beam probably acts as a ground plane above the tribander and keeps the signal from going up, I would guess.
Yeah. Yep.
Oh man. How does the gain compare to 2-element Yagi?
It's just a little bit below a normal 2-element Yagi, but not much. You're looking at 6 dBi gain on whatever band we're looking at on the hex beam, which isn't bad considering over a dipole, which is only 4. So you're doing better than a dipole, and you have directivity. Mm-hmm. Yeah, like I said, the antenna at 19 pounds. This is from WD3IT. Is it broadband on each band? Yes, it is, and it's easy to put on top of your roof as well. Like I said, it's 19 pounds. Because the antenna design is symmetrical. When the wind blows, it doesn't have a tendency of windmilling like a normal beam would windmill, because pretty much everything is being hit by the air at the same angle from both sides.
Emmett, do you have any non-amateur people using the hex beam?
Yes, we do. We have a couple 3-letter organizations that are using it on some specific frequencies that they like, and it's set up so that they can do their ALE type communications. They point in the direction that they want to go, and then the antenna itself works on the frequency, and they establish their link. The advantage being is that they don't have to use as much power to get from point to point, and that they get a little bit more OPSEC out of it. That means operational security, because they're not basically blabbering their signal everywhere in every direction.
Right. Okay. I think we've done a pretty good job covering the hex beam tonight. Let's see if there's any last questions on it, and we got a couple of things that we'll just throw in here in a minute. Let's see. I guess that's probably most of the questions. I think we caught most of them as they were happening. Now,
yeah, actually, KB2FJD. Yes, so it's like having a monoband antenna on each band, and that's exactly what you've got. You have an element designed for each band, and it works like a single element or a two-element Yagi, and it works quite nicely.
Well, I'm sure it's been used on QRP.
Yeah, definitely. I've got a couple people who do a lot of 10 meter, 6 meter. We make a smaller version that is literally 10 meters and 6 meters, and they take it out with them they backpack out with it. They set it up and they communicate on QRP because it's an efficient antenna and it's directional. So, like I said, the whole idea is that you don't have to use a lot of energy. It's efficient, so you're not wasting a lot. Getting things out on the air.
And you don't need a tuner, because each band is a resonant antenna, and it's
Right.
pretty broad-banded. So
Yes.
you may not go totally end to end of the band with a SWR you might like, but
Right.
it's pretty broad-banded in every band, right? So no tuner is really needed. And Emmett, man, you can get me into talking about antenna tuners here. I tell you, I don't believe in antenna tuners in the shack, especially if you run coax, and you're going to run coax up to that hex beam. I just feel like tuning that into that coax in the shack to get a better SWR does nothing for your antenna.
Well, the reality is, as my wife always says, you need to keep your issues outside.
Yeah.
So that's basically where I work. If I do use a coupler of some kind, I'll generally have it out close to the antenna itself, because
Right.
the closer to the antenna, if you have to use a tuner, you're better off. The antenna will bring the signal in and make things look like they're working really good, but the reality is you're also using your coax as part of the antenna system and everything else. So like I said, a resonant antenna is considerably more efficient as far as overall operations than a non-resonant.
And in my case, I got 138 feet of LMR 400 buried underground. I would not want to make that part of my antenna system.
Just a minute, I'm putting up a diagram real
Yeah.
quick. Someone asked for it. Here we go. Just a second. I'm trying to do my.
Yeah, Liquid Audio is asking a question. How can you plot your RF patterns? There's software out there that you can download and put in the specs of the antenna, which will give you some modeling, right?
Yeah, there are two ways of doing it. One is modeling on the computer, which isn't always correct, and then the second one is engineering. The way I have to do it for proving, for instance, if I was working at an AM radio station, I have to prove the radiation pattern of the antenna. So I have to go out and take signal strength measurements all the way around the antenna at specific points, so I can get it, I can basically plot out the pattern. In the case of a beam like this, what you'll end up doing is you'll do kind of the same thing, at a fixed location. You'll basically put an X signal out at certain signal strength, and you have a receiving antenna that's resonant at the frequency that you're working on, and as a standard, and you'll just start rotating the antenna. And as you rotate the antenna, you plot the increase and decrease in radiation, as it goes through its rotation, which is kind of cool. But anyway, this is someone asked another diagram of the antenna, and here's a little bit better one, where you've got your individual elements on the 20 meter. You got 6 meters, 10 meters, 12, 15, 17, and 20 meters. I'm not going to go into the broadband option at this time yet, but yes, we do make a broadband unit for it that gives you 80 through 30 on the same antenna with a different feed point, with a different feed. It's not as efficient, but what it is, it's like a terminated loop in the configuration of a pennant type antenna. So it acts like a rotatable dipole, which makes it absolutely killer for a lot of people. But I don't want to get into that yet. That can be in at another time, because that's a big discussion right there.
Yeah, okay. Well, Emmett, hey, one of the things I wanted to do, we've been on about an hour and 15 minutes now, and I'm sure there's several people that need to take a break out there, go get their drink refilled or go to the bathroom or whatever. And I want to talk to you about you've got a helper there, a 4-legged helper in the shack, and I want to just talk a little about that in a minute. And your helper also joined us at Huntsville. Some of the guys have probably seen this before. I'm going to put a quick little video on. You guys, if you've already seen it, go to the bathroom, go to the kitchen, get you a snack, and come back. But this has got a couple of our webcast members here. You're going to see Emmett in there. You'll see Joe Eisenberg in there playing the guitar. Emmett's up front. He does all the leg work. And you're going to see me in the background playing the saxophone. And there's a 4-legged helper that comes in there and joins us. So we're going to talk a little about that in just a minute. But this was at Huntsville, so here we go. That's not it. All right. Let me find it. That's not it. Here we go.
On a dusty road, good loving, I got a truckload, and when you get it, you got some, don't worry, 'cause I'm coming, I'm a soul man, I'm a soul man, I'm a soul man, I'm a soul man. Got what I got the hard way. I'll make it easy each and every day. So don't worry, don't you fret, 'cause you ain't seen nothing yet. I'm a soul man, I'm a soul man, I'm a soul man, I'm a soul man. Now listen, on a side street, I was educated from some good stock. When I start, I just can't stop. I'm a soul man, I'm a soul man, I'm a soul man, I'm a soul man. Well, grab a rope and I'll pull you in. Keep hope and be the only boyfriend. Yeah. We're on a mission from God.
All right. Well, I just wanted you guys to see that because, you know, in addition to always having fun with ham radio, we have more fun with ham radio. And Emmett's helper there joined us. They're right in the middle of the song, and I think helped it out. So, Emmett, what? Tell us about your helper there, your four-legged helper. Now, that's a service dog, right? Talk to us about it.
Yes, she is. She is as a matter of fact, well, that's my grandson. He's dressed up as Doctor Who for Halloween. Almost like the perfect young Who. Anyway, let me see if I pull up the picture here. This is Zoe. She is a German Shepherd, basically an East German Shepherd. We have two Shepherds. One is Zoe and one is Heidi. And generally you'll see Zoe with me at just about everywhere I go. You'll see Heidi with Rochelle just about everywhere she goes, and she's a beautiful black German Shepherd. We've trained both of these dogs as search dogs and rescue dogs. They're still in training. They're always in training. The idea being that if someone turns up missing, they help us. They're not a scent dog as far as trying to follow the scent of somebody. They are, but how do I get into this in the short time that I have? We basically train them to basically find what's missing. And she does an excellent job of that. She's also a great companion and also a fantastic protection type of a dog. She's well trained. Pretty much wherever we go, we can take her. And as you saw in Huntsville, she was in our booth. They will stay there in that booth for the entire show unless she hears me singing, and then she'll come and get me.
I worried. I didn't worry, but you get a bunch of adults in a small group like that jumping around screaming like they're fighting, and then here comes this German Shepherd over to protect its owner, and that dog was very, very tame and very trained. Yes. And knew not to bite or bother any of us, Hey, our harmonica player there, if you watch the video, our harmonica player kept a close eye on that dog, on Zoe there.
Yeah, she was a sweetie. The thing is about Zoe is that, She will not attack. In other words, she's trained not to do something like this. She does do protection, but that's only with a specific command. Otherwise, she's a playful pup unless she's trying to protect herself or me or Rochelle.
And the dog did sing a little bit with us if you listen closely.
Oh yeah, she could tell we were having fun. If you notice, she was really getting into, hey, I'm having fun, and that was her yelping, and it's almost like she's a puppy again in the litter.
Yeah, I thought you did a great job just quieting her down, and she just sat down, and we kept on doing our thing.
Yep. So anyway, that's the story of Zoe. Cool. By the way, she was a rescue. Her Zoe and Heidi both. Whoops, that's you, Tom.
What?
Both you and both. How do I say? Where am I at? Here we go. Let me see if I can find it real quick. I'm going to get the picture of Heidi that I have of her.
Yeah, you got me on there right now.
There we go. This is Heidi with Rochelle.
Uh-huh.
As you can tell, she's not a small German Shepherd. No. And they're both obedience trained. In other words, they're designed and they're also certified for public. They could go out in public at any time, and we can also take them generally wherever we want to go, as long as the rules allow us. And of course, if some venues do not like to have dogs, like believe it or not, a German Shepherd can be intimidating at times for people. Because needless to say, everyone thinks they're guard dogs, and they are. But they're kind of, how do I say it? Most people don't understand the dog, so consequently they fear the dog, and we don't want to be in a situation where we put the dog and the people in a position where they they compromise things.
All right.
So I guess what it boils down to is if a situation comes up where it looks like there's going to be stress in the environment, we generally don't bring the dog, and or we basically put our girls in a place where they're okay for for however long they need to be. And then, there we go. See, like I said, she's with me. Oh my goodness. What is that car?
Oh, what is that? Is that the Batmobile?
That's the Batmobile. One of the shops that are in our general area, one of the things
Yeah.
that he used to do is make Batmobiles. He also made other really cool cars. And anyway, that's
That
kinda
Batmobile would look really great if it had like a big bug catcher on it,
Yeah. Well, it's kind of funny because that Batmobile is built just like the original Batmobile. So it uses a specific car, sub chassis and everything else. So just getting the stuff together for it it's a classic in itself. Let's add a couple more pictures for you real quick. But as you can see, what I can do is I could go into the store, but I will not do that because it's not. Actually, it's not appropriate, but I could literally have Zoe sit in the car like that, and she would stay until I come back. And the same thing with when we're at a show, I'll have her sit down, or we'll have her, we'll give them a space, and that's their space, and they'll stay there until we tell them they can get up. And as you remember, Tom, you tried petting Zoe or trying to get Zoe and Heidi to come to you, and they wouldn't do it.
Mm-hmm.
That was because we didn't give them. We didn't give them permission to get up.
Yeah. All right. Emmett, I think we covered a lot of good things tonight. We had a lot of questions that came in. We normally do our hangout toward the end of the show where we allow people to join us. Right now, Jeff just logged in. He says no one's in the hangout. I'll log in here in just a minute, Jeff. I would like to hear, or just quickly, let me make a quick announcement. I would like to hear from people out there in the chat room that were having trouble with the main video. And if you went to YouTube, if you went to our backup video, I would like to hear from you how you felt the backup video worked in comparison to the main video. So give us some feedback. We're trying to fix things. The problem is we get people on here to talk about how it's buffering and it's dropping out, and then we've got other people on here in different parts of the U.S. saying it's solid and it hadn't dropped 1 minute. So it's an internet issue. We don't know where it is. It could be about anywhere, and we're just thinking it may be the backup server may have a different stream, the way it's handling it to your location or something. So we provided a secondary stream there. And let me say one other thing on the chat room, guys. If you look below at the bottom of the page on the right side, there's two buttons that says pop out chat. If you will pop out the chat and log in, then you will not lose the chat. For instance, right now, if you go from main video to video server, you'll probably lose the chat unless you have it popped out. If it's popped out, you won't lose the chat. You can go back and forth on the videos. So I just wanted to tell you that. We'll see how the nets went tonight. We're gonna in just a second gonna try to log in to Hangout and see if we got anybody on Hangout that wants to be on the show tonight. Emmett, thank you very much for being on here tonight. Emmett's a regular on our show every 2 or 3 weeks. We're gonna have Emmett on here and talk about antennas. I think next week Joe. K0NEB will be back with us. Joe, he's been out for a few weeks, but he's going to talk about kits, and also he's visited several of the Hamfest, local Hamfest there, and he's going to be giving us a report and some pictures on some of the Hamfest that he's attended. So with that, Emmett, 73 to you. You're welcome to join us on Hangout if you want to. If you don't, that's okay.
I really appreciate the time, folks. And one little thing before I go is definitely go out to that website, enjoythecode.com, and pass it on to your friends for learning how to do the Morse code, which I personally believe is a nice thing. It's a good thing to learn. Anyway, it was good speaking with you, Tom, and thank you very much for having me on. And if you want, have people send in their questions, and the next time we get on the air, we'll try and address as many of them as we can.
Sure. They just need to go to your website, Radio Waves, RADIOWAVZ.com, and I guess they can connect your own email to you. Probably there's a link with the email.
You bet.
And ask you questions there, and you can help them out. Thanks a lot, Emmett. We'll see you. We'll see you on the show here in a week or two.
Have a good one, Tom.
All right,
7
thanks.
degrees.
All right, bye-bye. All right, guys, what we're going to do next, we're going to try to get on Hangout, and we'll see who's in there. I think Jeff's in there, N3VE. He's always in there. So let me see what we're going to do here. I'm gonna have to cut Emmett off because I need this PC to get on. Bye, Emmett. We'll see you. All right, so let me get on here. All I got to do is find the link. There it is. All right. Well, looky there. Look who's in there. We've got Jeff in there. Where's that pop-up? Is that you or me? I guess that's me. Let me see. Yeah, it was me. We got Jeffrey in there up in New Jersey. We can always count on him. He's here for us.
Yes.
Just okay, guys. If you click on that link, click the link that Kathy put in there, or at the top of the chat room, you can see the link. If you'll click that link at the top of the chat room, you will see it, and you can click on that, and it will take you to Hangout, and you can be like Jeff. You can be a superstar on our show because we need superstars here for sure. There we go. So Jeff, how does the stream work? Oh, let's see. You tried to call a 75 meter or 80 meter net tonight. Did you get any check-ins at all? Oh, I'm not hearing you, Jeff. You got your mic muted? Let's see. No. Jeff always does this to me, guys. He does it on purpose. He either turns his microphone off or he turns his camera off. And he acts like he don't know it's off, but I'm sure he does this intentionally just to, you know. So he's working on it. He's working on it right now. Hey, we'll do this. We'll do this like they do the. We'll do this like they do the golf tournaments. And there's Jeff. Jeff is trying to get his microphone working. We think he can do it. Let's see how it's going. I like it. Flex 5000 he's got there. Boy, it's a beautiful looking radio. All right, you've had enough time. I'll be back with you in a minute. All right, so Jeff is going to work on his microphone. He's going to work on his microphone and get it going there. So